Hey, hi everyone. Good afternoon. Hope everybody is feeling fine. And yeah, are you able to see my screen and hear me? Please, you might want to participate in the poll. And perfect. Yeah. Oh, there are a few people who are not able to see the screen. You might have to reconnect, guys. 15%. 14%. Okay. Yeah, people who are not able to hear me, or see the screen, please reconnect. All right. All right, let's start the session for the day, friends. We'll begin now. So good afternoon, everyone. And yeah, hope everybody has subscribed to the YouTube channel, and you get the access to the YouTube videos. And already, I'm assuming you have downloaded the book from the website, 360DigiTMG website. Anyways, I will again demonstrating those things, how you get the material. But let's proceed on to the discussion of R programming. That's the main agenda, right? So let's start the session for the day. So we started understanding R programming, right? This is what we are trying to learn, R programming. And to begin with, R programming, open source and free software which is developed for statistical computing. Specifically, it was developed for doing statistical computing, and it is having functional oriented capabilities. And it was developed by two gentlemen whose name starts with R, Ross Ihaka and Robert Gentleman. So I'd say Ross and Robert Gentleman. Because of their names, right, you can say that programming language is also inspired and named after this letter. Now, R programming is very easy. It's like an English language, high-level language, and unfortunately, it is a single-threaded software. Right? So, if you have a lot of computation required to be done on R programming, probably it becomes a little lagged. That's a disadvantage. Now, when we talk about R programming, the R console is a command line interface. The R console is a command line interface, and we generally do not like, especially I don't like, writing the programs on that command line interface. So we use an IDE, interactive development environment, we call it as a GUI based application on top of R, and this is RStudio for us. And this, on the screen, what you are seeing, the application is RStudio. It has 4 different sections, 4 panes. This is the first pane, which is your script editor, or you can call it as a scripting page or scripting pane. This is where you'll write your code. Then we have the second part, which is the console. and this is where the execution of your code happens. Then you have environment tab. We also have history tab, and we have connections tab. Environment tab is giving us the summary of the objects or the variables that we are loading for our coding for a session, for particular sessions, this particular session. Right? Every time you are reloading a new session, the memory is getting flushed out. So you have to reload the environments into your memory. And then we have plots, files, packages, helper, viewer. These are the additional options, pins that we have for our programming. It gives us a very interactive environment for writing the codes by using a lot of graphical user interface options, user-friendly options in short. Now R comes up with a lot of documentation. You can click this help button and search for any function, any command that you want to read the documentation for. And in order to get the documentation, we are just question mark away. We can do question mark of command or the function, whatever you want to look the documentation for. Do a question mark, or you can also do help. Help of your command. R is case sensitive. This is something that we need to remember. R is case sensitive. And the index has a special quality. In your regular programming languages, the traditional systems, the index starts from 0, but for R, index starts from 1. The index is starting from 1. These are a few things, preliminary things that we need to remember by heart. Now, troubleshooting is one of the areas where R is very easy because it is an interactive programming. It's called as interpreted and interactive programming language. So line by line, every line that you are writing can be interpreted individually. You don't need to have an entire script to compile and interpret the code. And interactive, that means each line can be executed and we can interact with the program and understand what is the output that it is giving. Right? That's interactive nature of the R programming. So it gives you very easy, flexible methods to troubleshoot the errors. The disadvantage with the console is that, your programming is that, in console, you'll only see 1,000 lines printed at a time. That means if your R has to print output, then it can print only 1,000 lines. The rest of the lines are omitted, it doesn't show them. That's a drawback we have. Then we discussed about variables, right? A variable is nothing but a memory pointer, a name given to memory location where you are assigning a value. You can say this is a memory pointer where the object is stored. And the beauty of R programming is that you do not have to define or declare. It's dynamic in nature. You can just directly write a variable and then assign values to it. So declaring, defining is automatically taken care, and the value that we are trying to assign to this variable based on the value's data type, the variable's data type is automatically interpreted. Now the standards or the conditions that you need to remember with respect to variables in R are that the variable should or it can have alphanumeric values. It should start with letter. It cannot start with numbers. It can start with, or it has to start with letters. It can start with dot. This is allowed, right? And then a variable can have alphanumeric values. That means it can have numbers as well, but numbers cannot be used to start the variable. It can be in between or at the end. No special characters. No special characters to be used. The only two special characters that are allowed are underscore and, right, dot. These are the two special characters which are allowed. When you say dot at the start of your alphabet, then it is a hidden variable. It's treated as a hidden variable. Now these are the standards that you can give to, right, or give a variable, to give a variable. And of course, R is case sensitive. So you cannot use uppercase and lowercase as same variable. They are both two different variables. Then we also discussed about assignment operator. We are looking at operators, but as part of that, the first thing is assignment operator. Now, when you say assignment operator, we are talking about equal to symbol or arrow symbol. Arrow symbol is preferred, equal to symbol is not preferred. And when you say arrow symbol, the head is always pointing to the variable which will hold the value. The tail of the arrow will always hold the value that needs to be assigned. Right? So that's the assignment operator, arrow symbol. And this is left assignment. You can also have right assignment, but always remember, head will point to the variable, tail will point to the value. This is the assignment operator that we discussed. Then we also discussed about various other operations. To start with, arithmetic operation. Then anyways, we discussed about assignment operation. Then we have relational operations. We have logical operations as well. Right? We can also have identity operations or membership operations. Those are considered as miscellaneous, other operations. But yeah, these are the four primary operations that we have in R. Then we talked about, okay, let me talk about this. Arithmetic basically means what? You are talking about plus, minus, multiplication, division, ampersand. This is reminder. Right? We have basically double ampersand. This is for reminder. Then we have cap symbol. This is for your exponential, right? Power. Then we have relational operators or comparational operators. And here we basically look at comparing, right? So it will be equal to, not equal to, greater than, less than, greater than, equal to, less than or equal to. So these are different relational operators. Then we have AND gate and OR gate. Those will become your logical operators. And you also have OR operation. Right? And NOT also is there. NOT operator. These are different operations that we have with respect to R programming. We'll also use percentile n to verify identity. right? Or membership, you can say. These are miscellaneous operations. These are additional operations that we have in R programming. Then we looked at data types, and to begin with, the most atomic value in the data type is vector, right? In R, this is the most atomic value that we look at. But of course, we also have standalone atomic values as well. Vector is a sequential data, so you can have more than one specific data type. When you say data type, here we need to look at integer. We can look at double, right? Then we can look at character. Then we have factor, right? Complex, etc. These are basically the type. Of course, we also have Boolean. Boolean means your true or false, right? But yeah, when you talk about the data structures or data types, these are, to begin with, vectors. Vector is a data type, is the same data type would be there, right? And then it also has direction. So magnitude and direction. This is the definition of vector. But yeah, when you say vector, it has to have the same data type. Then extension to vectors, we have lists. Lists are nothing but vectors, but here you'll have multiple data types. We can have vectors also, different types of vectors as part of your lists. These are few things that we covered yesterday, till yesterday. Now today, we are going to discuss about matrix. Right? We are talking about matrices or matrix. Then of course, we'll also look at something called as factors. Factor data type is a special data type in R that we need to look at. And we'll try to look at the important data frames. Now, before I proceed, not sure how many of you have actually participated in the quiz. On our social media channels, we have quiz, right? So every day, at the end of the session, you will have quiz conducted on social media. So if you have not subscribed, do subscribe to it. This is YouTube. This is Facebook. Yeah, this is the quiz that I'm talking about. From yesterday's session, we have this, right, quiz competition. It's there on LinkedIn also. Yeah, this is Seth wrote. A lot of interesting information will be shared here. And yeah, this is the LinkedIn page. So every day you will have quiz, right? So register to these links and participate in the quiz. Right. So that's about social media. So yeah. Now, whenever we talk about data, right, the structure of the data is important for us. We need to look at the structure of the data, right? And this structure could be a one-dimensional data, a two-dimensional data, or a greater than two-dimensional data. Atomic vectors or atomic numbers are single values. Then you have vectors and lists which can be, right, added into one dimension. We can also have lists with two dimensions. We can create, right, lists with multiple dimensions. So that would become your matrix, for example. A two-dimensional data can be matrix. Now, when we are creating any object, we have yesterday seen, it's very simple. We just assign or create a variable and assign values to it. If you see the usage of this letter C, then that means you're combining multiple values into a vector. Now this is the default data abstraction in R. Right? A one-dimensional data that you are creating by default is a vector, and the vector could be of integers and numeric values, or it could be of character type. But vector can have only single data type. It cannot have multiple data objects. I can also create list from the vector, and we use this keyword list. And for every object in these iterable objects, right, every object that we are creating will have index, and that index starts from 1. So if you have multiple values, then this will become 1, this object will be 2, 3, 4, so on and so forth. So using the index value, we can access the data points. So if I say x of 2, that means you are referring to the second item of the object. Right? We are referring to the second item of the object. So you can refer to the index. And the index is represented in square brackets. Right? And we use colon to capture multiple values. Yeah. Right. This is how we can capture multiple values from a vector. So this, whenever you put square bracket, that means you're referring to only index. And minus value can also be used. Minus of the index number can be used to remove or not to consider those values which are represented in negative values. Then we've also seen the basic arithmetic operations, and if a vector is of same size, then you will be doing element to element addition or multiplication or subtraction or division for that matter. But this is at the vector level. And if you have different sizes for your vectors, then R will multiply or put round robin fashion of values. So this small vector is repeating itself to meet the size of the larger vector. Vector value to vector value is what we are trying to do the operations on. Right? And because we don't have any value here, you cannot do the operation. And R says, let's replace it. Just extend this again like that. This is how we do vector operations. We can also do sort function. You're sorting, arranging the data. Right? By default, it is in ascending order. By default, the sort, right, it gives you the data in ascending order, smaller to larger value. And the smaller to larger value, if it is numeric, fine. But if it is non-numeric, then that ordering is happening based on alphabetical order. The first letter of that particular character is considered. First letter. Right? That's how sorting is done. And then to create lists, we just use this list keyword. Okay, that's how we create the lists. We can also have lists within a list. And to get list, we take a vector and use the keyword to convert a vector into a list. And if you want to convert a list back to vectors, then we use unlist. Unlist is the function. Right. That's list of vectors. These are a few things that we discussed yesterday. Now let's talk about matrix today. Okay, we are now talking about matrix. Now what is a matrix? To start with, a matrix is a two-dimensional object. Right? It's a two-dimensional object. And it contains rows and columns. When it says two dimension, it contains rows and columns. Right? And the values within a matrix in R should belong to the same data type. Right? You cannot create a matrix from list. Right? I mean, that's what we do, but list can have different data types, right? So you will have to create matrix from vector data types. That basically means what? Your elements in a matrix should belong to the same data types. And how do we create this? For creating list, we use list function. For creating matrix, we use matrix function. Right? Very simple, matrix function. Next, one thing you need to remember is a matrix will always have a fixed length. When I say fixed length, I'm not saying that you cannot change the matrix dimension. What I mean is, if you say n by m, that means you're saying n rows and m columns, then all the n rows should be of exactly m size. You cannot have one row like this, the other row like this, other row like this, other row like this. You cannot have this difference in the dimensions. Each row should contain the exact number of columns. The dimension should be consistent and same. Now, how do I know more about the matrix function? You can simply do a question mark here. Easy, right, in R? You just press question mark and say matrix. Look at that, it is prompting you. And just do enter. I mean, so control enter. This gives you the documentation. And whenever you're trying to write a matrix or create a matrix, there are certain arguments which are mandatory. One is the data, and the other one is matrix, right? So it needs rows and columns. So you're defining how many rows and how many columns should be there. These are mandatory arguments that you need to pass. Data, rows and columns. Right? We also have various other arguments that we can do. By row. By row is false. By row is how do you want to fill in the data in matrix format. Right? It's by default false. But if you set it to true, then the data that you are passing in, the vector data that you are passing in, will be arranged in rows. The precedence is given to rows first, so fill the rows. Right? So that's basically your default arguments. Then we have DIM names, dimension names. Right? These are the names that will be given to rows and columns. You can specifically label rows and columns in the matrix using this DIM name. So let's create a random matrix, right? Just for fun, we'll create a random matrix. So let's say M, you assign this, I'm creating a variable M, and you're assigning matrix to. So I'll say matrix, and within this, let's pass data. Now, in order to pass the data, let's probably start with a list of vectors. Okay, let's say probably 1:6. 1:6. And this I'm passing as, let's say, rows and dimensions is what I have to give. So n rows is equal to 1:6, right? So let's pass 2 rows. And by row is equals to, let's say, true. By default it is false. Let's say true. I'll execute this. Oh, sorry. True. So your matrix M, if you say M and execute it, you will see that the data is arranged in a 2x3 matrix. Why? Because you are defining that you need 2 rows. And you are saying by row true. Right? So your data is a vector of values 1, 2, 3, 4, 5, 6. You want 2 rows. Row 1, row 2. Fine. But how are you going to arrange the data? By row. So first, fill the row. You're saying 1, 2, 3. But you need 2 rows, right? So it is dividing this exactly at this. Now, if you change this to false, if you say this is false, then see the arrangement here will change. You'll get 1, 4, 6, 1, 4, 5. Right? Not 1, 4, 1, 3, 5. Yeah? Observe that. I've changed to false and I'll print again M. You see 1, 3, 5. So now you are saying you want 2 rows, fine. But you are not saying by row. By row false means you want the data by columns first. So you're saying fill the columns first. You want 2 rows, but fill the columns. So 1, 2, 3, 4, 6. Right? So this is how you are going to give the names, the dimensions to your matrix. You can also change this rows to 3. And you can remove this. By default, it is taking false. You said 3 rows, right? So it is adding 3 rows like this. So you will basically decide on how many rows you want on the given vector. We are taking vector, remember, because we need same data type. And then on that vector data, you are deciding how many rows and how many columns you want. Right? So this is your vector length. Now on this vector, if you have this vector, how are you going to access the data? You want to access a specific value. How do you access it? So here we represent the data in square representation, right? Index in square representation. Now, if it is a vector, then you are going to represent vector in a single square bracket. The index will be represented because the index will be like this. So a single row and multiple columns will be there. Single row, multiple columns. That's your vector. But here when you say matrix, you have 2 dimensions. You'll have rows and columns, right? So in order to access the data of the matrix, you will represent square brackets, rows, comma, columns. Right? So let's show you that. So we'll say m square brackets. Let's say 1, comma 2. So let's take this into 10. And let's say by row equal to true. Submultiple, it cannot be multiplied. Oh, 3, right? So you cannot have, let's take 9. Now I'll get a square matrix. Now 3 by 3 matrix is what I'm getting. And on this 3 by 3 matrix, you want to access 1, comma 2. 1, comma 2. Remember I said row, comma columns. So you're referring to first row, second column entry. That is this 2. If you change this to 2, comma 2, then you will get 5. Second row, second cell. You can also represent only row number and leave the, after comma, don't mention anything. It will print you the entire second row. You can also put row as empty and right, pass the value. So you're taking second column, so you'll get 2, 5, 8. Right, second column is printed. 2, 5, 8. 2, 5, 8. Right, so this is your matrix data access in R. Now, how about doing some kind of addition? Or let's say we'll do arithmetic operations on this, okay? Simple arithmetic operations. So let's do division. I need to create 2 matrices. So I'll say M1. And for M1, I'm saying it's a matrix. And then let's create some random numbers. C of, let me take small numbers, okay? Any other one more. 3, 6, 7, 8. So I'm creating a matrix here, and let's say number of rows could be 3. Okay, let me take a smaller data set just to understand, right? So I'm taking M1 as a 2 by 3 matrix. You can see M1, it will be a 2 by 3 matrix, right? Now let me also create M2, and we'll say C of some random numbers. Okay, minus. N row is equal to, I'm defining M2. So 2 by 3 matrix and a 2 by 3 matrix is created. Now matrix addition. Matrix addition. So I'll say capital M is equal to, or it is being assigned to, M1 plus M2. M1 plus M2. So what will happen when I do matrix addition? It's a 2 by 3 matrix. So what will I get? I get simple matrix value to matrix value addition. That means my addition here, my matrix will become 9, 5, 17, so on and so forth, right? So 9 and all that. So let's show you that. You can see here it's just adding the values. 2 plus 7, 9. 4 plus 1, 5. 7 plus 10, 17. 3 plus 6 is 9. 7 plus 5, 12. 9 minus 3, 6. Simple value to value addition. You can also do subtraction. Let's say M1 here. This is addition. I'll do M2, capital M2, where I'll say M1 minus M2. Now what will be the M2 value? It's a simple location to location or cell to cell subtraction of your values. Right? So you will get, this is your M1 and M2. So 2 minus 7, which will become minus 5. 7 minus 10. Right? 7 minus 5, so on and so forth. So you get these results. Now when you are doing subtraction, here you are doing 9 minus of minus 3. So it becomes 9 plus 3. You're getting 12. Now how about division and multiplication? Let's talk about multiplication. In matrix, we know division is something which is tricky. Where we don't have direct division in matrix, but in R we can do that. Right. So if I talk about multiplication, can I do M1 multiplied by M2? Yeah. Can I do a matrix multiplication? M1 minus M1 multiplied by M2? Now here, if I use a simple matrix multiplication, then I can do that. Let me show you. M3, M1 multiplied by M2. I can do this straight multiplication. It's not a matrix multiplication, to be precise, exact. Right? This is a simple vector to vector multiplication that we are doing. Value to value multiplication that we are trying to do. Yeah. So this matrix multiplication is, the multiplication that you are seeing is not actual matrix multiplication. It's a simple matrix vector to vector multiplication. Right? So you can do it. This way you can do it. It's not an actual matrix multiplication that we are doing here. Okay? You have to remember that. We do have a different way to do the calculation for, right, for matrix multiplication. We use a different function altogether. Right? And this multiplication that you are seeing is a simple vector value to vector value multiplication. If you put percentile, then it will treat as a matrix multiplication. Right? So that's a different concept altogether. We'll discuss that later. Similarly, when we talk about matrix division, then that's a trick that we need to look at. We do not actually have a matrix division, right? Can I do matrix division? It's not defined. You will have to do a multiplication of matrix A with inverse of the second matrix. That's how division can be interpreted, right? So that's matrix calculation. We do inverse of the original matrix and then do multiply that inverse with A. So that's how division is taken care of. But here we can do a straight division again. We'll simply use division command. So we'll say M4 M1 division by M2. Again, this is also a vector to vector division. Right, you are getting a vector to vector division. This is M1, this is M2. Right? So this is how we get the simple arithmetic operations that we can perform on matrices. We are just arranging vectors, guys. Okay, don't get confused here. We are just converting the vectors into a two-dimensional arrangement. Okay, so that's your simple matrix applications that we can do. Next, let us move on to discuss about the concepts of greater than two-dimensional data. So we have looked at matrices, right? We have looked at vectors, we have looked at lists, now we are looking at matrices. But what if you have greater than two-dimensional data? Yeah, you have greater than two-dimensional data. So in mathematical terminologies, we arrange this data as arrays. A single dimensional array is nothing but your vector or list. Two-dimensional array is a matrix representation. Now, in R, we can represent the data objects which are greater than 2 dimensions by using array function. We simply use array function. Right? And again, just like matrix, array will consider this array will be used to consider vectors as inputs. Okay, we'll just take vectors as inputs and then we'll create multi-dimensional vector. But again, we need to pass the arguments. So we will say arrays. So we'll simply do question mark of array. Right? This is your syntax, array syntax. It will take, just like your matrix, it will take data, then it will take dimensions. Yeah, how many dimensions you want to create. So let's look into that. So multi-way arrays. So data can be taken and dimension, length of the data, dimension names are passed. The dimension attribute for the array can be created. This is an integer vector of length 1 or more, giving the maximal indices of each dimension, right? So these are the bare minimum variables or arguments that we need to pass into arrays function. Again, remember we said we can pass multiple vectors, right? So let's look into this. Now, a two-dimensional array that we created is also an array, right? That is also an array. Let's create this, right? A simple arrays. Let's assume that we have vectors, okay? The same m1, m2. We'll take this m1 and m2 as vectors here, rather than matrices. We'll take this m1 and m2 as matrices. You can have different size vectors. Let's take that. I'll take this vectors, okay? But again, these are two different data types. Let me recreate them. That's it. L1, 2, 3, 4, 5, 6. Right? Or let's have 6. It'll be easy. Right. So I have one vector which is of 6 size dimension, length is 6. And another vector dimension is only 2. Right? Now, in order to create an array with these vectors, we can say A array is equals to array of, you can pass vectors as inputs here. Multiple vectors. So again, we'll say A1, comma A2. These are your inputs. But what are the dimensions that you want these data to be arranged? So you'll say dimension is equal to. Again, you have to pass multiple values. You're going to say, probably will create row size, column size, and right, we need to give matrices. Okay, we'll do this. Three by three. Okay, row size, column size, and how many matrices you have to create. So this is an array. Look at this. This is an array, multi-dimensional, right? 3 dimensions are there. So this is 1 dimension. Yep. And then this is another matrix. So it takes the first dimension first, that is, first vector as the first entry, 1, 2, 3, 4, 5, 6. And then it takes the second matrix, which is 1, 2, 3. Right? And it is creating 2 such matrices. Right? Yeah. Let me take the questions. I think there are a lot of questions which are irrelevant questions. Let me address those questions. Ramanand, what's your question? It's not wrong, Ramanand. I clearly mentioned that it is not the actual matrix multiplication. We will look into those things. Please hold on. We have so many things to learn, right? This is a simple matrix representation of the data where we are doing multiplication of vector objects only. Okay, so actual matrix multiplication we will learn. In fact, I told ampersand multiplied by ampersand. That's the symbol that we use. Please hold on, guys. You need to have a little patience. I will cover all those things. Don't worry. Okay, you have all those things. I'll explain, guys. Please hold on. Huh? The same answer for Safety for you as well. We will be learning all those things, don't worry. Why you are writing like array? That's how it is written, right? It's a multi-dimensional object. Array is a multi-dimensional object. Are you using mobile, Shitisha, by any way? If you are using mobile, you will not be able to see the screen. You have to change to computer. Okay, I think yeah, those are the questions. Fine. Yeah, so array is a multi-dimensional objects, friends. So we basically are giving this, right? You can imagine like I'm trying to have a 3 by 3 matrix representing twice, right? It's like a 3 dimensions that we have, right? So I'm giving the name as well here. If you see, I can also assign name to it. This is the first matrix, which has a 3 by 3 matrix, and this 2 is basically talking about how many matrices we are combining like that, right? So here we have another 3 by 3 matrix. This is how we generally represent in matrix. I mean arrays. Okay, the array function, it takes vectors as inputs, right? And we use the dimension, that is the parameter, to define the array dimensions, right? We can give any dimensions here. Say for example, if you get a dimension like probably 1, 2, 3, that means it is creating 3 matrices of dimension of 1 by 2, that is 1 row and 2 columns. 3 such matrices will be created. That's how your arrays are designed in R. Now if you want to access the value of this array that you have created, then you are going to basically define the data in a square representation again. See, for example, here I'll represent this. I'll try to access value of A. A is an array, right? I'm saying, let's say 2, 1, 1. So 2, 1, 1 means it is trying to capture the second row, first column, second row, first column of the first matrix. It is giving you this, right? If you change this to, let's say, 2, then it is referring to this matrix, right? This is how we can represent your values. Let's say I'll put it as 3, 3, 1, 2. So third row, first column of second matrix, that is 3, right? So these are your matrix multiplication, array representations in your R programming, right? So we can also do various manipulations, but we will take the steps slowly. We'll try first digest these array representations, right? And then we will look into the different manipulations. It's just matrix manipulations, remember, okay? Rather than this arrays, right, we have to try and learn on, let's say, data frames in a much better way. Data frames are the default abstractions in R, not arrays. When you are representing your data in R, right? The default abstraction is considered as a table. Okay, and any transactions that we are on, majority of the transactions that we are doing are performed on this data frames only. Okay, so array of course is a data structure, but yeah, not many applications are performed. We can do one function on array, which is apply function. We can use this, right? And apply has a syntax where it says what is the function that you want to apply on your array, right? And that margin basically is considered, I mean, let's do a question mark and explain that. So if you say question mark of apply, then you can see the syntax. It takes array as an input. It also takes the margin as an input. And fun is not fun. It is function that you are trying to take in. An array, it could be also including a matrix. Margin is a vector giving the subscript. And then function is what is that function that you are trying to apply on top of your array. Right? So these are the objects, I mean, these are the functions that you can apply on arrays as well. So let us try and do this. So I already have an array called A, right? Now on this array, you might want to perform apply function, right? So let's do this. So I want to do sum here. I will use apply function. I will pass array as an input, right? And then I'm passing the vector, right? So here, remember the object margin is a vector of values that you are passing, right? Across all the matrices, it is applying a sum on all the elements of the rows that we have, right? So let's do that. So I will say, let's say column 1, I mean first row, and what do I want? I want to do sum. Yeah. So let's get S, you get 2. Right? So it is doing sum of all the matrices. We are using the sum of rows across all the matrices. Right? So what is the sum here? Um, 6, 6, 12 you got, right? Sum you are applying on to your first value, isn't it? Then what is the second one? What is that you are getting here? 9. So you're getting 18. Sum of the matrices here, the rows basically. So this is margin, right? And then 24. That is nothing but this one. Rows sum of both the matrices. If you change this to 2, then it would be the sum of columns. Okay, you pass that as your input, right? X is an array, margin is passed here, which is a vector. You can say either 1 or 2. 1 represents rows, 2 represents columns. And then you are applying sum of those values. Right? So that's your apply function, which can be applied on arrays, a multi-dimensional data as well. We can also do simple addition of your matrices. I mean, it's just like your addition of matrices, right? So we can also do that. So we created vectors, then we converted that vectors to a list by using list keyword. We can also convert the vectors to matrix by using matrix keyword. Similarly, we are passing multiple vectors to create arrays using array function. For array, you can pass input as a vector. Right, so these are the basic foundational concepts that you need to remember. Okay, next. What's the time? It's 3:12 now. Right, let me see your questions and then we will take a apply. Okay, I'll explain. How to convert vector to a matrix? You just use matrix function, Joseph. How to calculate the transpose of matrix in R? Just T will be applied. That's a function that you can use, Shashidhara. We'll look into that. Just say T. Values and dimensions in arrays. It takes 3 values. Okay, I think. Let me also do it. Okay. I have a vector, friends. Right? It is a one-dimensional object. If I say matrix, then it needs 2 dimensions, right? So the input that I'm passing here will be a vector, and then those dimensions. You pass those dimensions, that will create 2-dimensional object. That becomes your vector, matrix. For array, you are saying it is greater than 2. So in R, it treats that greater than 2 objects as matrices only. So you are saying dimension is equals to rows, columns, and matrices. How many matrices you want to have? This is array. So you are passing input as vector only again. Your vector is taken and is converted, reshaped into these dimensions. Right? So that's how R deals with these preliminary data objects. Now coming to apply function, you're passing data. You're passing data. And then you are saying margin. Margin is either rows or columns. And then you are passing the function. Right? So here I have array. Here I have array, right? Which basically has 3 by 3 matrices, 3 by 3 matrices, and 2 matrices. That means my dimension was 3, 3, 2. Okay, my A is 3, 3, 2. Right? So that's your rows, columns, and 2 matrices. So I'm saying margin is equals to row. Row means 1. So you're saying array, comma 1, comma sum. Sum is addition, right? How do you want to add the values? On row wise. On this data. So row is what? This is one row. This is the row, right? So we are adding these values and these values. All the rows of all the matrices in array. Right? So this is how it is adding the results. So 6, 6, you get 12. Then it takes the second row. 9 plus 9, you get 18. It's just adding. This is how much? 12 plus 12, 24. This will be the result of your apply function when you are doing it on rows. You can also do it on columns. You can just say 2, comma. And now you see, get sum of columns. 1 plus 2 plus 3. How much is this? 6. Plus 6. What should be the result? 12. What is this? 10 plus 5. 15 plus 15. You get how much? You should get 30. Again, this is 1, 2, 3, 1, 2, 3. So you get 12. Right? That's what you're getting. Sum of columns. Yeah. Alright. So play around, guys. Play around. You have the documentation. Everything is available. It's just a question mark away. Right? It's just a simple question mark value away. Alright. So we'll take the break now. Post the break, we will talk about the other data types that we need to look at, which is factors and the data frames. Very important. Okay? Alright, so it's 3:17 now. Now let me see the questions. I think you missed out Venkat Kaliprasad. You have to focus. We discussed on how to access that. You use square brackets. Okay, fine. So we'll go for the break now, and then we'll come back and continue on the other objects. It's 380. So we'll connect at 3:28. Okay, before the break. Okay, let me not write the time. Before the break, I want to again showcase the social media channels and the YouTube. It's happening live now, right? So you need to connect to this link. I see a lot of people are asking me, share the link, share the link. Not required, friends. You connect, subscribe to this. You don't have to ask anyone. As soon as the session becomes live, you get the access here. Right? So subscribe to this channel. Not only this, there are a lot of interesting information that is getting circulated here on the social media channels, and your social media channel, your page should contain all these relevant information. So you need to connect to these social media channels. This is for your betterment. Okay? So don't think that unnecessarily I'm asking you people to attend do all this, because see, we are living in digital platforms, digital world, and the entire world is looking into these digital platforms. And if you are not active on this, if you're working on silos, then trust us, you lose on a lot of opportunities, right? Yes. So be active on social media. Subscribe to these channels. Not just these channels, everywhere, wherever you can get the right advantage of getting relevant information, take right advantage. Connect to that. So let's now take the break. 3:20, 3:21, but yeah, we'll connect back at 3:30. All right. Let's connect back at 3:30. Omkar, we will be sharing that. Not to worry, we will be sharing it today. You can see them on the YouTube itself. I don't need any book for R, guys. So that's something that I can very clearly say. Don't right, invest in any book at this point of time. You have everything there that is required on help here. So you just go through the document first, right? So we will be able to get all those details that are there here. Right. Yeah. So we discussed about arrays, we discussed about lists, we discussed about matrices. Now we will discuss about factors. Okay. Factors is another data object, a special data object rather in R, which deals with categorical data. Right? It categorizes the data. And the data will be stored in something called as levels. Factor type or factors are nothing but the data objects which are stored in levels. These are finite set of values which may be repeating, and for each finite value or unique value, there will be a level assigned. Level is nothing but an integer number, 1, 2, 3, 4. So we compare this level with that number. So when you have a data like, let's say, COVID positive, COVID negative, positive, negative, male, female, right, or different country names are there. So all these categorical data, right, can be converted into factor type. So when you are actually trying to work with data analysis, right, for statistical modeling and all that, converting this categorical data into levels would be very, very, very handy. And we use factor. Factor is the function that we apply. Just like how we have list, how we have matrix, how we have array, we have factor. And we execute this to get the document. The function factor is used to encode a vector as a factor. Categorical data, right, will be ordered. Right? And we can also verify the data as using this is factor, or you can convert the data into as factor. Right? These are additional functions that you have in converting your or in working with your categorical data. Now let's try and create a factor from a vector. Let's say I have a simple vector. On top of that vector, I'm creating it as a factor. I'll create a factor. I'll use the keyword factor, and then I'll create a vector inside this. So let's say I have A, then I'll have, let's say, B, I'll have again A, I'll have C, probably I'll have B, then again B, then again I'll have A, let's probably say E. How many are that? 1, 2, 3, 4, 5, 6, 7, 8, right? So we'll have 2 more. Right. So these are your vector objects, right? This is your vector object. So I'm creating a vector of these characters, and then I'm converting that vector directly as a factor. Okay, so let me create this vector separately also. You might want to see that. This is a vector. I'm printing it, right? So let's do vector. And here you can see V is character. On the right side, top hand side, you can see V is shown as character data. The length is 10 units, 1:10. Right? That's your data type. You can say class of V. Right? And when you say class of V, it says it's a character. Now, you are converting that character into a factor. Now, if you observe here on the right hand top corner, you can see that the data is now converted into a factor with 5 levels. It says factor with 5 levels. Right? You simply say factor. Right? Now you can also see print F. You can say F here. It will be printing like this. And you can see here, these are the levels. It is identifying the unique values in your vector. And for each vector, right, it is treating that as a level. For each vector, it is treating it as separate level. You can also alter the levels, friends. You can change the levels. Yep. So here I have A, B, C, D, E. Right? This is my level. Now, if I want to change the order of the levels, let's do that. You just have to use a function called levels. So I'm changing F2, a new factor I'm creating, and say factor of your vector. Either you directly pass here vector, or you can type the entire values. And then you use a keyword argument called levels. Right? You pass argument called levels, and here you are going to give the levels. Let's say I will say E, B, A, C, B. I'm altering the order basically for these levels. E is not found. E is not found. E is not found. E is not found. A, B, C, D, E. Object E not found. Okay, let me just cross check this. Oh, okay, my bad. These are characters, right? Sorry. These are character data, so I have to put them in quotes. These are your levels. Now, if you say F2, see the order here is changing. When you say F, the levels are A, B, C, D, E. By default, it is alphabetical order, but you can override by using levels keyword. Whenever you have a huge data, right, and these values are repeating themselves, then you can convert that into factor type. And you can identify how many levels are there in that particular factor type. Now there is a function called structure. All this while we were using class, right? Now I'm using structure, STR. And look at that. Structure is basically giving the insights on the object. So it says it is a factor with 5 levels. 5 level means 5 different levels are there. E, D, A, C, D. And for these values, alphabetically they are given order there. A takes 1, A takes value as 1, but yeah, here you are giving the value as, by default, A takes 1, if I say F, but here you are changing the order. So A becomes 1, 2, 3, 4, 4, 5. Right? So if you define your object F2, which is your vector, A is what? 3, right? So this is 3. B is 5. Again, you have 3. Right? Then you have 4. Then 2, 2, 3, 1, 3, 5. So it is internally looking at the level. If you say structure of F, then you can see A, B, C, D by default. This is the straight alphabetical order. It's a straight alphabetical order. And A is treated as 1, 2, 3, 4, 5. So you have 1, 2, 1, 3, 4, 4, 1, 5, 1. It's just addressing the level on numeric scale. So it is ordering the data. This is factor type, especially when you're working with non-numeric data, categorical data. Then you would want to convert the data into factors first. Right? This is one of the special data type that you have in R. Factor types. Next, the most important one, we have data frames. Right? You can say data frames or data space frame. Data frames are a two-dimensional array, or you can say it's a matrix representation, or you can say it is a simple table representation of the data. Okay, it's a simple table representation of the data. Now we need to understand a difference between a two-dimensional array, that is your list or a matrix, to data frames. When you say a list, and if you say a two-dimensional list, for example, let's say I have vectors, okay? I've created a list with, I'll say a list of V1, V2, V3. Assume these are your three different vectors using which you created a list. So V1 could be 1, 2, 3, 4. V2, it could be A, B, C, D. A different data type, character type. V3, you can also have double values, let's say 10.5, 10.2, or whatever the number is, right? 20. So I have a vector here, three different vectors, and I'm creating a list on top of this. So it's a list of V1, V2, V3. When I do this, I would get the arrangement of list as V1, V2, V3. That means your arrangement will be 1, 2, 3, 4, A, B, C, D, 10.5, 10.2, and 20. This is how you get your list. Now I cannot create this as a matrix because the length of the third vector is not equal, or it's not of equal size of vector 1 and vector 2. Right? So vector 3 is of only length 3, so you cannot create a matrix directly from this vectors. That's a drawback. Okay, this is to only discuss the difference between list and data frame. Okay, so this is your list. Now, if I convert or create a data frame, remember data frame is a table. It's a table representation. Right? So the vectors are arranged like this: vector 1, vector 2, vector 3. right? In data frame, we store data or data in table format, and the vectors will represent as columns, as separate variable, right? So this is your data frame, friends. Yes. Now the representation will be 1, 2, 3, 4, A, B, C, D, and 10.5, 10.2, 20, and here you'll have anyone, no space. So that's the difference between a list and a data frame. So in short, to summarize, list is taking the vectors on rows, whereas data frame takes vectors, each individual vectors on columns. Yeah, it's a two-dimensional structure. Data frame is a two-dimensional structure which contains values in column, right? Each vector will be treated as a column and it's one variable, right? So that's how we basically represent your data frames. Now for the data frames, one very important thing is it is always represented in something called as key and value pairs. Okay, dictionaries, we call them as dictionaries. And each vector that we are talking about will have to be identified by a name. And that name cannot be empty in data frame. Or in short, in simple words, when you say data frame, you're representing that in table. The vector names are coming here. These are headers. The names, right? You also call them as keys. These headers cannot be empty. The column names should not be empty, right? That's something that you need to look at. And creating a data frame is very easy, right? And each column can be of different data type. Remember that. In a single data frame, each column can be of different data type. So let us create a simple data frame. It's a table that we need to create here, okay? Let's create this. So let's say I'm creating a two-dimensional data, basically a data frame, by creating vectors. So let's say I'm creating V1 is a vector. I'll say 1, 2, 5, or 8, 4, 8, 9. Or let's say 6. Okay, fine. This is vector 1. Then I'm creating a vector 2. Here I can have a different data types. I'll say A, probably I'll say Z, I'll take, let's say G, some random. And then E and probably P. Okay. Some random characters I've assigned this into a vector. V1, V2, and let's say V3 is also created. Okay, we create third vector as well. And as I said, it could be a decimal values. 11.1, 20.6 or 20.5. You can have probably 45. Then you can have 879 point, let's say 2. And some random numbers, 3 point, let's say 8. So we have integers data type, we have character data type, we have double data type or decimal data type. Right? Now I'm creating a data frame here using these three vectors. So if I say L1, first I'll create a list of V1, v2 comma v3. Okay, I'm creating a list of v1 comma v2 comma v3. I've executed this and then I'm creating a list row. So I'll say L1. And you can see here, you're getting list 1, sorry, vector 1, vector 2, vector 3. It is capturing or arranging the data in row format. Now we will create a data frame from these vectors. I'll say data dot frame. Data dot frame. v1 comma v2 comma v3. Why is this throwing error? Let me check. v1 comma v2 comma v3. 5 different number of rows. Arguments imply different number. Okay, let me just show you this. Question mark of data dot frame. When I execute this, it gives you the instructions. So you're just passing the data. These arguments can be either of form value or tag or vectors, or it could be anything. Then you're saying row names, right? You're creating row names, or you're creating a vectors. Strange why it is throwing error is something that I need to figure out. Vector 1, vector 2, vector 3. I've created vectors. df data frame is created as data dot frame. Let me just try this. Okay, it's coming. v2, it's coming. v3 is how much? 1, 2, 3, 4, 5. This also should come. Some issue with v3. 1, 2, 3, 4, 5. Okay, my bad. I have 6. This is not possible in data frames. My bad. I have 6 objects there in data frames. Now let me create a data frame with these values. So data frame is created. Now if I say df, see the difference between list and data frames. So this is a list. You simply say list of v1, v2, v3, and then you say data frame also, and check data frame. You can see how these values are getting arranged. In list, the values are treated as row objects, right? Whereas in here, in data frame, we are treating each of that value as a column, right? We are treating them as column. So this is a table arrangement with the vector names as the column headers, right? We are having column headers there, right? So this is basically the data frame structure. Now we do a lot of operations, all the operations in fact that we do on the data frame itself. So statistical computing, or you do any kind of analytics, data preparation, or machine learning algorithms to be implemented will be done on this data frame structure only. Now here we say str of df, structure of the data frame. When you do this, It clearly shows that the data frame is the structure name, and it has 5 observations. Observations means rows, and 3 variables. Variables means columns. And observation, right? I mean, here the observations, the rows, are represented, right, with the data type. So you are saying 3 variables. Variable 1 has number, right, or numeric value. So it doesn't treat it as integer because you're not passing sequential value here. If you say v1 type class of v1, it will be showing number only, numeric values only. v1 is numeric value, right? So that is saying numeric value is assigned here. Then v2 is a character data by default, but in the data frame, it will convert the data into factor by default. So you can see v2 here on the right side top corner, it says character data. It's a vector, right? And the values of that vector are character data only. Whereas here, in the data frame, when you check the structure, it shows a vector with 5 levels. So it's converting that vector into a factor data type. Right? By default, it is converting that. You can pass arguments to make sure that it doesn't convert. Right? We have something called as strings as factors as an argument. This one. By default, it is changing that data type to factors. If you say false here, then it will not convert the data into factors. Right? But by default, it is true. Sorry. And then the last one, which is numeric data, it is representing that as numeric data itself. So this is your structure. STR means structure of the data. We can also do summary fields. Now we will have to deep dive into the summary function. We will do that. Summary is giving the breakup of those vectors. Statistical computing is happening on the data and it gives you a report. Right? It gives you detailed statistical computing reports there. Of course, only on numeric data. On non-numeric data, it is doing only the count value. So this is your data frame. Right? So as part of today's session, we try to discuss or we try to extend our understanding of vectors from lists to matrices. We've yesterday discussed about the vectors and lists. Today we try to understand matrices. It's a two-dimensional object of vectors. Then we also discussed about arrays, which is greater than two-dimensional objects. Then we looked at factors. Factors are categorical data. For categorical data, we use this data type. And then the default data abstraction in R, which is nothing but table representation, which is a two-dimensional data, is what we are looking at. And we will be working on data frames a lot. Right? So we will be looking at a lot of vectors, factors, and data frames. So this is your summary. Then we have, this is the data frame functionalities that we discussed. You just create data frame using this command. Data.frame. Right? And then we create array using array function. factor using factor function, list using list functions, matrix using matrix function. Now for all these functions, right, all these functions, you will use help documentation, the documentation that is by default provided by R, to practice. And just do a question mark of that function and you get examples as well, right? You can practice on the examples. So this is what you have to do. Data dot frame. Right, so these are today's discussions. All right, let me see if you have any questions and then we will proceed further. Clear before. If I clear Ramnath, then a lot of people who are trying to follow up on the code, they might miss it. That's the reason I'm keeping it there. That Harsha factor data type is internally dealing with that, ordering the data based on alphabetical order. It is assigning a numeric level. Factor data type does that. Yes, Ravishan. Rajavari Saraswati. Yeah, that's correct. Yeah, Nivas, I later on realized that I had passed 6 values, 6 elements. Yeah. Rather than 3.8, I put 3 comma 8. So that was the mistake. Yeah, a lot of people have actually identified that. Wonderful things. All right. Mallikarjun. They are not related, Mallikarjun. R and Python programming are not related. There are certain features which are similar, especially when you talk about functional programming. R also has support for functional oriented language, and Python also has that functionality. That's one thing which is common. And now in data science community, data analyst community, both these programming languages are being utilized. Right? So that's the similarity between R and Python. If I have to compare both, R is a statistical programming, Python is a general purpose programming. In R, you can only do statistical computing or mathematical related calculations or machine learning related stuff. Whereas in Python, you can do web development, you can do video game development, you can write a testing code, you can do anything in Python. Another advantage with Python is it's a multi-threaded programming language. That means you can configure multitasking. Whereas in R, that's not possible because R is a single software. But from statistical computing, R is a lot matured and a lot inbuilt functionalities are readily available to make the life of programmers very easy and to get the desired results. Right? R is easy from that perspective. So if you are not a programmer, and if you want to venture into programming, then probably you might want to look into R programming. Yeah, Neha is also responding to it. All right. Raman, you have to type in, don't copy paste everything. You have to type in the code. Only then you learn. I'm also typing everything, right? I'm trying to type the code wherever possible. Right? So access to the YouTube videos will be given. Go through the recorded video and try and practice it. And wherever you're stuck, use this question mark. And unless until you type in from scratch, you'll not remember things. And if I see, scroll down all the way, you have so many examples here. You can start doing with these examples and try and understand the function. Not just data frame, you'll basically learn a lot of things when you try to do that. Right? So practice from that perspective. Anyone can deal with that, Varshit. You just have to understand, right? These foundations or fundamentals of your mathematics, which everybody has covered in their school days. There's nothing like non-mathematics background. These are all fundamentals, right? Array, matrix, vectors, lists. Just trying to revise them, and you are dealing with the data from that perspective, the arrangement perspective. If you can understand the data, yes, you can. All right, friends, so let's wind up the session for the day. And yeah, tomorrow we will try and learn about functions. Of course, we'll have to look at strings. Then we will look at functions. And probably, yeah, we'll try and understand packages as well. So those are the things that we will be covering tomorrow. Yeah, very good, Raman. Yes, wonderful. All right, thank you, friends. Yeah, more interesting things coming, friends. These are only fundamentals, right? You'll enjoy. All right, guys. Thank you.